Hello students and welcome back to my channel. Today I have come up with questions based on general properties of matter and simple harmonic motion waves and all. These questions have been asked on 30th January 2023 JEE mains. So without wasting time, let us discuss them. Uh, so you can see the height of liquid column raised in a capillary tube of certain radius when dipped in liquid A vertically is 5 cm. If the tube is dipped in a similar manner in another liquid B of surface tension and density double the values of liquid A, the height of liquid column raised in liquid B would be. Now, see here students, if you dip a capillary, okay, in a liquid, it will rise, isn't it? That is known as capillary rise. The capillary rise formula is 2t cos theta upon r rho g, where what is r? R is the radius of the capillary tube. R is the, once again I have to draw. Okay, this radius r. Rho is the density of liquid, and theta is the angle of contact. Angle of contact is the angle made by the meniscus with the uh, surface of the vessel inside it. Okay, usually it is acute angle. In the case when liquid rises, it is an acute angle. Okay, so now here you see in the second situation you have some other liquid, so probably surface tension would have changed, then density would have changed, and of course cos theta would have changed. So I can write H is proportional to T cos theta by rho, the height of liquid column raised in a capillary. If the tube means the same tube is being continued, so radius remains same and the experiment is being performed in the same place, so G will also remain same. Now there's a small problem here students. It's not clear what do they mean when they say is dipped in a similar manner. We have not been informed regarding the angle of contact. So here we have to assume that angle of contact is also constant. Only then we'll be able to solve the answer. So perhaps in a similar manner means theta is same. So then we are left with H is proportional to T by rho. So if we can find the factor of change for H by knowing the factor of change of T and rho, then we can get the answer. So the surface tension and density are double. So surface tension is double and density is also double. So factor of change for H is 1. So factor of change is 1 means there is no change at all. So the final answer is also 5 centimeter. 5 centimeter converted into meter will give C option 0.05. So the height capillary rise remains unchanged. Okay, moving on to the next question. Choose the correct relations between Poisson ratio, sigma, Bulk's modulus, and modulus of rigidity. Now, students, usually this is actually out of syllabus because these questions or these concepts are learnt in first year or second year engineering college. Okay, mechanical engineers, civil engineers, architectural engineers, all these students they study this in the subject which is called as structural mechanics or strength of materials. Strength of material they study this, okay, or structural analysis 1, structural analysis 2, whatever it is. But still they have given this, I don't know how they have given, but anyway, if you refer to some standard textbook, then you will get this like Young's modulus is equal to 2 eta into 1 plus sigma, okay, and also Young's modulus is equal to 3k into 1 minus sigma. These formulas you can obtain in some standard books, okay, and in engineering college books it's very commonly available. So we can eliminate y to express sigma in terms of what eta and k. So if we equate them, you have 2 eta plus 2 eta sigma is equal to 3k minus 3k sigma. Okay. So therefore, we require sigma, isn't it? Yes. So sigma can be obtained as 2 eta plus 3k, and sorry, I'm sorry. This is 2 sigma actually. By mistake, I have written this. This is actually 2 sigma. I'm sorry. So this will become 6. And this side you have 3k minus 2 eta. So this goes below this. So numerator is 3k minus 2 eta, denominator is 6k plus 2 eta. So first option is the correct answer. Okay, right. Moving on to the next question. A force is applied to a steel wire A, rigidly clamped at one end. As a result, elongation of the wire is 0.2 mm. If the same force is applied to another steel wire B of double the length and the diameter 2.4 times that of the wire A, the elongation in the wire B will be. Now, students, solve these questions in the same manner which I am solving. Okay. Otherwise, so unnecessarily it will consume time. So first to write down the expression for the elongation of the wire. They are asking elongation. No? Write down the formula for elongation. So just start with the basic formula. Basic formula is longitudinal stress is equal to y into longitudinal strain. Here by longitudinal stress I mean normal stress. So normal stress is force restoring force per unit area, and this is change in length by original length. So accordingly I can write change in length as FL by AY. L goes up and Y comes down. Okay. So here just see the same force is applied. So F is same, and a force is applied to a steel wire and another steel wire. So both are steel, so Y is same because Young's modulus of elasticity depends only on the material of the wire. Here both the materials are same, and we are left with what? L and cross section area. Cross section area in terms of diameter is pi d square by 4. In other words, it is this. Okay, because I have eliminated constants. D is the diameter. So let us find the factor of change for delta L. Factor of change for L is how much? Double the length. So factor of change for L is 2. For diameter it is 2.4 times. So 2.4 means 24 by 10 whole square. This will be 2 into 10 into 10 by 24 into 24. Okay. So now factor of change is the new length by original length, or change in length, sorry. What is the original change in length? 0.2 mm. 0.2 mm. Okay. So from here we can find delta L dash. So delta L dash will be, now since answers are in terms of 10 power minus 2, 10 power minus 2. So let us multiply and divide by 100. So this will become 20 into 10 power minus 2 mm. It goes up. We are left with, let us cancel this. 2 5s are, 2 12s are, 2 5s are, 2 12s are, and 2 6s are. So we have 5 into 5 upon 6 into 12. Is it? Then we have 4 5s are 4 3s are. So this will be 5 into 5 into 5 is 25 upon 6 into 5 by 3. So 25 by 6 is 6 fours are 24. So 4 point something, and 5 by 3 is 1.67. Okay, 6 fours are 24. Is it? Right. Now you see, students, 4 16s are 64. Isn't it? 4 16s are 64 and it should be more than 64. So more than 64 with a point. So the only option left is C option. 69. I mean, when we put decimal, 4 point and into 1 point, certainly it will be 6 point something. Okay. So that's how you have to reach the correct answer. Moving on to the next question. For a simple harmonic motion in a mass spring system shown, the surface is frictionless. When mass of block is 1 kg, the angular frequency is omega 1, and when the mass of block is 2 kg, angular frequency, the ratio of this. So first we have to write the relation for the angular frequency in terms of mass. If k is the spring constant and m is the mass of the block, then we all know that the restoring force acting on the block is minus kx square if x is the displacement of the block from the mean position, which is also equal to minus omega square x. Sorry, this is x, I'm so sorry. So accordingly, omega square is k, sorry, mass should be there, isn't it? I'm sorry. So this is now acceleration will be force by mass. So force by mass. So this is equal to minus omega square x. So accordingly, omega is under root k by m. So this formula you have to remember, students. So omega is equal to under root k by m. Now since in both the situations the spring remains same, so k is a constant, k remains constant. So we can write that omega varies inversely as square root of mass. So based on that, I can write final value of omega upon initial value of omega is equal to under root initial mass by final mass. Initial mass is 1 kg, final mass is 2 kg. So D option is the correct answer. Then moving on to the next question. The general displacement of a simple harmonic oscillator is x equal to a sine omega t. Let t be its time period. The slope of its potential energy versus time curve will be maximum when t small t equal to capital T by beta, where value of beta. Now students, you can see this is a general displacement equation for a particle undergoing SHM with initial position as mean position. If initial position is mean position, that means what? The initial phase or the phase constant is zero. There is no initial phase. Right. Now, in many cases, you can simply correlate SHM with the spring block system. Okay. So the potential energy is actually equal to potential energy of a spring is how much? Half k square. Very much similar to that. Why? Because force is equal to minus kx in case of spring block system, and in case of SHM also it is force is equal to minus kx. So that is how you can draw an analogy between any simple harmonic motion in general for that matter and spring block system. So where k is m omega square. Okay, k is m omega square. So you can see that potential energy is m omega square by 2. For now, I'll write it as some constant k, and x, I'll borrow the expression for x from here, and it will be a square sine square omega t. So we have to obtain the slope of this. Slope means du by dt. Slope of u versus time graph means du by dt. So when you differentiate this, you have 2 sin omega t into cos omega t into omega, chain rule of differentiation. And accordingly, I'll merge all these constants into a single constant, let us say k dash, and I'll write this as sine 2 omega t. You all know 2 sine theta cos theta is equal to sine 2 theta. So accordingly, so this is maximum when this will be maximum, is it? And the maximum value of sine is 1 when, for the lowest value, when angle is pi by 2 radian. So I can write this as maximum value as 1 when this angle is pi by 2 radian. Okay. Now we all know that omega can be written as 2 pi by capital T. In case of simple harmonic motion, we can always write this. So let us cancel what all things get cancelled here. Only pi gets cancelled, you can see. And accordingly, you have t equal to capital T upon 8. 2 into 2 into 2 is 8. So correct answer is 8. Beta is 8. Moving on to the next question. The velocity of a particle executing SHM varies with displacement x as this. The time period of oscillations is x by 7 seconds. The value of x is right. Now students, you should remember this formula. The velocity of a particle executing SHM is this. Okay, I am not deriving this. Okay, you can get this in any textbook. So squaring both sides, we have v square is equal to omega square a square minus omega square x square. So remember coefficient of v square is 1. So rewriting this, I can write dividing both sides by 4. Dividing forward by 4, I can write like this. Okay, so comparing these two, I can see coefficient of minus x square is omega square, which is 1 by 4. So coefficient of x minus x square is minus omega square, which is minus x square is omega square, which is 1 by 4. So omega is equal to half. Okay, but we know omega is 2 pi by t, isn't it? So therefore, time period is 4 pi. Okay, so pi is 22 by 7. So this becomes 88 by 7. So correct answer is x is 88. X is 88. That's all in this video, students. Thank you for watching my channel. If you like my way of teaching, kindly subscribe to my channel and hit the like button. Thank you.